Hi class, this is Miss Liu. We have learned about some special trig ratios in the past. Today, let's explore how to use them to derive a simpler way to find the missing sides of two special kinds of right triangles. First, we need to determine which kind we're working with. So there are two kinds. One is a right triangle with a 45-degree angle on the inside. So notice the other one is also going to be 45 degrees, which makes this triangle isosceles. So that means these two sides have the same length. So let's say we know this side is 1. So immediately we would know this side is also 1. So how do we find the hypotenuse of this triangle? Well, the Pythagorean theorem says a squared plus b squared equals c squared. So in this case, 1 squared plus 1 squared is going to equal 2 squared. So we know that the hypotenuse, which is c in this case, is going to be root 2. So we know it's root 2. The thing is, we don't have to use this every time we solve a triangle, because if we change this to just x, meaning it could be any length, so then we still know that this side is going to be x, and this side is going to be square root of 2 times x. So let's look at another example. If we were given that this side is gonna be, let me change the color real quick here. If this side was given to us to be 9, immediately we would know that this side is also 9, and this side would be then square root of 2 times 9, which is just 9 square root of 2. So what if we were not given the shorter sides? What if we were given the hypotenuse? Let's say that we know that this side is gonna be 5. So how do I find out these two sides? Well, we can look at it this way. Since square root of 2x equals 5 in a sense, so then when we solve for x, then we would have 5 divided by square root of 2, and we could simplify it by multiplying square root of 2 top and bottom. Well, it doesn't really have to simplify it a lot, but we would get this to be the length. Well, since x is just 1 times x here, so we don't have to multiply that by anything. So then we have our answer. These two sides are gonna be that. So what we can summarize from here is that if we have a right triangle that has a 45-degree angle inside, then we would know this configuration, the x, x, and square root of 2x. And we won't have to use anything else to derive it. So that helps us to solve the problems really quickly. So let's look at another case here. Let's look at a case where we have a right triangle and we have a 30-degree angle. Now sometimes the problem might give us 60 degrees. Well, we would know that the other one is immediately 30 because they have to add up to 90. Okay, so let's say that we know that one side is 30. So let's say if this side was given to be 1, what would the other two sides be? Well, we could always do sine of 30 degrees equals a half equals opposite over hypotenuse. So hypotenuse, let's call it x here. So when we solve for x, we would know that x is 2. And what about the adjacent side? Well, we already know that, we could use another, like cosine, or, well, let's just use cosines. Cosine 30 degree is square root of 3 over 2, and it's also the adjacent, let's call this x right here, adjacent over, I'm sorry, yeah, no, I'm right, adjacent over hypotenuse. So when we solve, we would know that x, which is the adjacent side, is going to be square root of 3. So guess what? This configuration works on any right triangle with the 30-degree angle inside, no matter how big the length is. So we can change these to just x, meaning it could be any size, and this then would be 2 times x, and this one would be square root of 3 times x. So now let's try something very similar to the last problem. Let's say that we are given x is square root of 5. So what would this side be? Well, since x equals square root of 5, so this side then would be root 3 times root 5, and we can simplify a little bit, and it would be root 15. And this side would be 2 times square root of 5, and would be just 2 root 5. Sometimes it's a little bit trickier where we're given not the side where the unit is just 1. Sometimes we're given, say, the hypotenuse is square root of 6. Notice that the opposite side is exactly the half of the hypotenuse. So very quickly, we could just divide this hypotenuse divided by 2 on each side, and then we would get half of that is just root 6 over 2. So now we know that this side is root 6 over 2, then this side would be just root 3 times that, oops, and it's gonna give us root 18 over 2, which we could further simplify to be 3 root 2 over 2, because when I multiply this by 3 again and then put it back inside, it's gonna give me 18. So I know this answer is correct. So this side would be this, the opposite side would be this, and this was already given. The hypotenuse was root 6. And here's how you solve the missing sides. So how do I find the other side? Well, this side is exactly half of this. So in order to find this side, we just immediately divide that by 2. So now we would have this. And this side, well, it's a little bit trickier, but we could just solve for x and then plug it back in, just like we did on the last problem. So how do we solve for x? We would just divide 2 on each side. And on this side, when you divide 2, you're just multiplying at the denominator. And we're going to have root 6 over 4. But this, remember, is just x. Okay, so when we find this side, we can't say this is the answer. We have to plug this x all the way back in here. So then we would have root 3 times root 6 over 4. And in this case, we'll have root 18 over 4, which we could simplify, and we're gonna get 3 root 2 over 4. Let me check if it's true. If I multiply this back in, it would be 2 times 9. Yes, so yeah, this would be the answer for this side, which is the adjacent side. And this was given. It was one of the conditions would be the hypotenuse. And we found that opposite side is just root 6 over 2. So the trick is we will remember this configuration, and we need to know that the adjacent side is exactly the half of the hypotenuse. This is one of the most common property of this type of triangle. So there you have it, a faster way to find the missing sides of special triangles.